Hey guys, welcome to another day of pre-calculus class. I know you're as excited as I am to get started with your most favorite class. Today is Thursday, the 22nd, 8/22, and let me give you some quick heads up on some items. I'm still not quite sure how we are going to do homework. You should have been doing it all along. As you know, bring your homework with you. The dreaded Monday that I'm sure no one is looking forward to. This Monday, I believe it's the 26th, but either way, it's this Monday at 8:30 a.m. Yes, you heard that correctly, 8:30 a.m. And bring your homework with you. I'm not sure yet if I'm going to collect that, look at it. We're going to get this figured out. You're definitely getting a grade for it. You were definitely supposed to have done it, and so bring that with you Monday. Our test will be Monday, and I'm going to explain a little more about that at the end of the video today. So your test will be Monday, and some of you will take it on Monday. Some of you will choose to take it home with you Monday, and again, we'll talk more about that at the end of the class period today. I was going to talk about the review sheet, but let's save that for the end of the video, okay? You will more than likely need to pause the video a lot today, so I'm going to go as fast as possible like usual. I hope you guys are doing great. Hope you're having a great week. I joke about this being your favorite class. I'm sure you dread a lot of this, but you're getting a good education, and let's continue to work really hard. We're going to get out of this review chapter, hopefully, Lord willing, sometime next week. And then we're going to jump right ahead into the trigonometry chapters, and you'll find that really challenging, but you'll also find it cool. It's really neat. I'm trying to find out. I'm looking through the book now. What chapters is that? Looks like chapter 7. Looks like chapters 5, 6, and 7. We're going to jump onto those chapters, and then when we're finished with those, we'll go back to chapters 1 and work our way through the book. Okay, grab your notebooks after that. Excuse me, my voice is a little rough today, sorry. After that little speech there, hopefully you're ready. Grab your notebooks, get ready to take some notes today. And we're going to look at two different topics. And then at the end of the video today, I will explain the review sheet and how you're going to get ready for your test. Okay, your heading today, well, there's two headings. We're going to start off today with looking at finding domains of rational expressions. Okay, write that in your notes. This is the last, I'm going to try to make this the last time that I say this. You are going to have to pause the video. I'm not going to wait for you to write things down, so I'm going to keep moving. And again, my philosophy is not one of being impatient. You can always slow me down by pausing, but you cannot speed the videos up if I'm going too slow. So I try to go fast, and I expect you to pause the video, okay? So here we go. We're going to start off today by looking at a topic called Finding Domains of Rational Expressions. Lesson R.5, the review chapter, section 5. And the date today, if you like to keep track of those types of things, which I think it's very important, is 8/22. 8/22. Now, first of all, what is a rational expression? Well, here it is. I'm not going to test you on the actual definition, but a rational expression is a fraction in which we have a polynomial in the top for your numerator and a polynomial in the bottom in the denominator. And that's a rational expression. It's that simple. And today we're going to find the domains of rational expressions. Now, what do we mean? And you take notes here on whatever you feel like you need to take notes. I'll leave that up to you. But what do we mean when we say the domain of something? In mathematics, when we say, what is the domain of this function or this graph or this rational expression, what do we mean by what is the domain? Well, domain is this, and I would encourage you to write this down, okay? The domain is simply this. It's what x is allowed to be in a given mathematical situation. Let me say that again. Domain is what x is allowed to be in a given mathematical situation. Now, that's probably not as technical as a lot of math books would put it. A lot of math books might say something like this. Domain is all x that's defined, or something like that. But I think this is a little more simplified. It's what x is allowed to be in a given mathematical situation. Now, I know it doesn't mean a whole lot, but let me kind of explain what that means, okay? All right. What that means, in other words, how do I find the domain of a rational expression? What does that mean, what x is allowed to be? Well, let me kind of talk to you about that for a second, okay? In your notes, I would like you to write this down. 3 over 0. Okay, write that down. And then write, let me rephrase that. Let's put fraction. Write this down. A fraction and you should know this by algebra from algebra 2. A fraction can never have 0 in the denominator. Okay? Now, if you got to pause the video, I'm going to go back here for a second. Look at this last example right here. Okay, x plus 5. Now think about this, would you? What if I put negative 5 in for x? Just pretend I put negative, everywhere there's an x, I put negative 5. Well, if I put a negative 5 here, what's negative 5 plus 5? Well, it's 0. So if I put a negative 5 in for x, notice what I get in my denominator. I get a 0. And remember what I just said, you can never have 0 in a denominator. So for this rational expression, I know that x cannot equal negative 5. Do you see how I did that a little bit? Let's go back to this comment right here. A fraction can never have 0 in the denominator. So when I give you a rational expression and I'm asking you to find the domain, one way to do that is to find what x cannot be, and then of course everything else x is allowed to be. Hope that made sense. We're going to find out what x can't be, and then by process of elimination we know that everything that x can be would be the opposite of what x cannot be. So if x cannot be negative 5, then x is, or your domain is, all real numbers except for negative 5. So what we're going to do today is we're going to realize that a fraction can never have 0 in the denominator, and we're going to find out what makes the denominator become 0, and then we know that is part of the domain that does not exist, because you can never have 0 in the denominator. Let's go ahead and jump in and see if we can't make this a little clearer. Okay? Go ahead and copy this problem in your notes. Let's start off with this rational expression. Okay, on your test, I would say to you, what is the domain of this rational expression? Well, as soon as I look at x minus 3, I realize, hey, there is no way x can equal 3. Now, another way to do that is take the denominator, x minus 3, set it equal to 0, and then solve. Add 3 to both sides, and then we see that x equals 3. So in other words, when you put 3 in for x, you get a 0. Or you can kind of do it in your head. That's what I do. I just simply say, hey, what would I put for x right here that would make this whole denominator become 0? Well, 3. 3 minus 3 is 0. So with that in mind, then I know x cannot equal 3. So my answer would be this. I would say domain would be all real numbers such that x does not equal 3. There's your answer. So what is the domain of this function? Or in other words, what is x allowed to be? X is all real numbers except negative 3. All right. Okay, let's continue on. Let's take a look at another problem that's a little more difficult. What if I asked you to find the domain of this expression? Now, obviously, this one's going to be a lot more difficult because I have a quadratic polynomial down here. But hold it. Remember we've learned how to factor the denominators? Well, I just had a thought. If I could break this thing down into parentheses, I'm just making this up, like x minus 5, x plus 3, then it would be really easy to see what x could not be. And so I'm thinking, I'm going to factor the denominator when the denominator is not as easy as this problem here, x minus 3. I'm going to go ahead and factor the denominator, and I think that'll make it a little easier. So let's kind of see what happens here. Well, first of all, if I'm going to factor the denominator, I'm going to pull it off to the side here and do some factoring. First of all, I pull out what's common. There's nothing common. Secondly, I say to myself, okay, self, am I left over with a binomial or a trinomial? Well, I'm left over with a trinomial. Okay, fine. Does it have a lead coefficient of 1, or does it not have a lead coefficient of 1? Well, it does, and that's the easy kind. All that I have to do is list out all the factors of negative 5. So 1 times 5, 1 times 5, positive times a negative, and negative times a positive. Now, one of those adds up to negative 4, and it's going to be this one right here. So my factorization would be x plus 1, x minus 5. There we go. So I'm going to come up here and very neatly just cross this off. And in place of that, I'm going to put x plus 1, x minus 5. Well, Mr. Earhart, I don't see how that helps a whole lot. Really? You should. Look at this. I mean, now, what would make this parenthesis become 0? A negative 1. Negative 1 plus 1. And what would make this parenthesis become a 0? 5, because 5 minus 5 is 0. So these are two values that x cannot be. So what would the domain be? The domain would be all real numbers such that x does not equal negative 1 and 5. There we go. Do you see how we're doing this? Let's try one more, okay? And then we'll move on to another topic for today and we'll be finished, okay? All right, let's find the domain of this rational expression. Let's find the domain. Well, first of all, I'm going to factor the denominator. Now, it looks like they have already very kindly and very politely pulled out an x for us, and there's nothing else we can pull out. So that's fine. Look at what you're left over with on the inside of the parentheses. It is a binomial or is it a trinomial? What's a trinomial? Does it have a lead coefficient of 1 or does it not? Yes, it does. And thankfully it does, because that's the easy kind. So, and by the way, I got these out of the book. Is that the exact? No, it's not the exact same problem. Okay. And so I'm going to list out, I do have a lead coefficient of 1, so I'm going to list out all the factors of negative 5. So 1 times 5, 1 times 5. Positive times a negative, negative times a positive. Now only one of these will add up to a positive 4, and it's this one right here. So I'm going to bring down my x, and I'm going to put two parentheses, and my factorization would be x minus 1, x plus 5. I'm just going to very neatly cross this off. So there's my denominator. Now, let's start with this parentheses over here. What would I put in for x that would make this group become a 0? Well, a negative 5. What would I put into this group to make this parentheses a 0? Well, a 1. And now look at this x all by itself over here. This is so easy it's hard, okay? It's so easy it's difficult. What would I put in for x right here to make this group a 0? Well, just simply 0. I mean, if I put a 0 in for x, then this whole group right here is 0. So, here are three values x cannot be. So, if x cannot be those values, then my domain would be all real numbers such that x does not equal 0, 1, and negative 5. There you go. That's the domain. That's what x is allowed to be. X in this rational expression is allowed to be all real numbers except for 0, 1, and negative 5. There you go. Not too difficult. So what you just learned how to do was find the domain of a rational expression. Okay? And what it basically comes down to is asking yourself this question: what makes the denominator become 0? All right? ask yourself that question, and you should be able to find what x cannot be, so then thus you'll know what x can be. All right, let's move on. Go ahead and copy this in your notes, please. Now we're going to look at simplifying rational expressions. Simplifying rational expressions. Now I know this video is a little long, so it probably seems like it's been a whole day, but it's not. It's still the same day, so 8/22/13. And we're looking at simplifying rational expressions, lesson R.5. All right? Now, let me give you some steps I think would be very wise for you to write down, okay? I'll leave that up to you, but I think it's very wise to write down steps. If I go too fast, just pause the video. When you're asked to simplify a rational expression, the first thing you want to do is factor the top and the bottom, the numerator and the denominator. And then next, after you've factored, then you want to reduce the factors or parentheses that can be reduced. Okay, so those are the two things you want to do when simplifying rational expressions. Now, to give you a little closure, we're going to do 1, 2, 3 problems, and then we're going to talk about the review sheet for a little bit. All right, so here we go. Let me go back one more time. Factor the numerator and the denominator, and then secondly, reduce the factors or parentheses that can be reduced. Okay, would you please copy this into your note? I want you to simplify this rational expression. Simplify it. All right, well, first of all, I'm going to start with the numerator up top. In fact, you know what I'm going to do? I'm going to split this thing up. I'm going to go ahead and put 9x squared plus 6x minus 3 over here, and I'm going to put the denominator right here. And what we're going to do is we're going to factor both of these. All right, so here we go. Let's start off by factoring this. Step 1, you always pull out what's common, so I'm going to pull a 3 out. There's no x's I can pull out, so I'm left with 3x squared plus 2x minus 1. Okay, so after you factored out a 3, what are you left over with? You're left over with a trinomial that does not have a lead coefficient of 1. Now, these are the more difficult ones, okay? We do not have a lead coefficient of 1, so remember what to do. We bring this 3 that we pulled out down here, kind of get rid of it. Now remember, we take our lead coefficient times our last term, we write it right over here, okay? So 3 times negative 1 would be negative 3, and we're going to list out all the multiples of negative 3. 1 times 3, 1 times 3, positive times a negative, negative times a positive. Now only one of these adds up to a positive 2. And it's these two numbers right here. Now, do you remember what to do next? You take your middle term, your 2x, and you write it with two different terms. So we would put a negative 1x, and why a negative 1? Because of this number here, and why an x? Because my 2 has an x with it. And then next I would put a positive 3x by using this 3 over here. And now bring down your last term, which is a negative 1. Bring down your first term, which is a 3x squared. Now, you should have 4 terms, and now we're going to factor this by grouping. We learned how to do this the other day. So I'm going to pull out what's common in the first 2 terms right here. I can pull out an x. There is no whole number I can pull out. So x times 3x is 3x squared, and x times negative 1 is negative 1x. Now here's a dilemma over here. I can pull nothing out. I cannot pull any x's out of both terms, and I cannot pull any constant terms out. So in that case, when you're dealing with these last 2 terms, when that happens, then go ahead and pull a 1 out. And when you do that, you would put here on the inside 1 times 3x is 3x, and 1 times negative 1 is negative 1. And now notice your 2 parentheses match, so I'm going to write my matching parentheses 1 time, 3x minus 1, and I'm left over with x plus 1. Okay? So I have taken the numerator right here, and I have factored it all the way down to this right here. All right, now let's take a look at our denominator. All right, first of all, you're going to factor out a 12, and when you do that, you're left with x squared minus 1. And then you're going to say to yourself, okay, self, am I left over with a binomial or a trinomial inside the parentheses? Well, it's a binomial. Okay, fine. Do I know the square root of both of these terms or the cubed root? Well, I know the square root of both of them. Okay, so I'm dealing with perfect squares. When I'm dealing with perfect squares, the first term has to be positive and the second term has to be negative, and that's what I have. So we're ready to go ahead and factor this thing. So Bring down your 12. We're going to put two little parentheses. The square root of x squared is x, so I put an x here and an x here. The square root of 1 is 1, so I'm going to put a 1 here and a 1 here, and we make one positive and we make one negative. So we took our denominator and we factored it down to this right here. Okay? I hope everyone's seeing that okay. Let me go ahead and do some quick erasing here without losing all the work that I just did, so thanks for your patience. Alright, and now I'm going to go ahead and write my new numerator, 3 parentheses 3x minus 1, x plus 1. And now my new denominator is 12, x plus 1, x minus 1. Okay? And now let's go ahead and simplify whatever I can simplify. Oh, by the way, let me go back to the very beginning of the problem. Would you all watch this for a second? I should have said this at the beginning and I didn't. That's very poor teaching and I apologize. You know what a lot of students want to do at the very, very beginning? I'm going to do this. I'm going to do that. And let's see. Cut that out of there for a second. You know what a lot of students do when they first look at this problem that I gave them? They say, oh, x squared. Oh, x squared. And they cross it off. Ooh, a 9 into 12. 3 goes into 9 3 times, and 3 goes into 12 4 times. And they just start crossing things off. Now, the problem with that is this. You have 3 terms up here, students, and you have 2 terms down here. You can't just start reducing things unless you have 1 term up top and 1 term in the bottom. And we don't have 1 term up top and 1 term in the bottom. We have a lot of terms, okay? So you are not going to be able to do that. Now, here's what we're going to do. Now that we have taken this fraction and we have totally reduced it, now we can start simplifying. For example, see this parentheses x plus 1? Well, that cancels with x plus 1. Now, this x minus 1 here does not cancel with 3x minus 1. However, I've got a 3 and a 12 right here, constant terms, so 3 goes into 3 once, and 3 goes into 12 4 times. So my final answer would be 1 parentheses 3x minus 1, and then in the denominator 4 parentheses and then x minus 1. Now you should know by now you don't have to have this 1 out front. If you do, this is totally acceptable. The back of the book would probably just have this up top, 3x minus 1, no parentheses, 3x minus 1 over 4 x minus 1. More than likely, that's what the back of the book would have, but if you want to put a parentheses here and put a 1 on the outside, that's totally acceptable. All right, so let's go back. You always factor the numerator and denominator and then reduce the factors or parentheses that can be reduced. All right, let's go ahead and move on to your next example here. Okay, I'm going to write my numerator right over here, 4x cubed plus 16x squared. I'm going to write my denominator right over here, 2x cubed plus 6x squared minus 8x. And let's roll. Here we go. Let's factor this right here. First of all, I can pull a 4 out, and I can also pull out 2 x's. So I'm left with x plus 4. X plus 4. I think that's right. Let me check it and see. Yes, that's correct. And now over here, I can pull out a 2, and I can also pull out an x. So I'm left over with x squared plus 3x minus 4. Okay, remember how to do that? 2x times x squared, 2x cubed. 2x times 3x, 6x squared, etc. Okay, now that you pulled out the fact you factored out, let's go back over here. I'm sorry, I apologize. I factored out a 4x squared. I'm left over with a binomial, correct? Do I know the square root or the cube root of both terms? No, I do not. I know the square root of 4, but I do not know the square root of x. I do not know the cubed root of both of those, so I cannot factor this binomial any further. Now let's come over here. I have a trinomial with a lead coefficient of 1. Those are the best kind. They're the fastest, okay? All that I have to do is list out the factors of 4. So 1 times 4, 1 times 4, 2 times 2, 2 times 2. Notice it is a negative 4. So positive times a negative, negative times a positive, the negative, Positive times a negative, negative times a positive. One of these groups adds up to a positive 3, and it's that group right there. So bring down your 2x, and then put your two little parentheses, and you would have x minus 1 from right here, and then x plus 4. So there we go, students. Okay, so now we have our numerator and our denominator. Let me bump all this down real quick, out of the way. Did not mean to do that. Okay, we have taken our numerator and our denominator, and we have totally factored those, so that's good. And let me get some of this out of the way here. Did not mean to do that. All right. All right, here we go. So for my numerator right here, I'm just going to extend this line. For my numerator, I'm going to put 4x squared parentheses x plus 4. And then for my denominator right here, I'm going to put 2x parentheses x minus 1 parentheses x plus 4. And now let's go ahead and start reducing and simplifying. My x plus 4 cancels with my x plus 4. Here's an x minus 1. I don't see any x minus 1s up here, but look, I've got a term. This is one term, 4x squared, one term, 2x. So I can do some simplifying. First of all, 2 goes into 2 once, and 2 goes into 4 twice. Then I have 2x's here and 1x here, so I can take 1x away from here as long as I take 1x away from up here, and I'm left with 1x. So it looks like to me I'm left with 2x over x minus 1. Here's my 2x, 2x over x minus 1. Now, if you want to put a 1 in the denominator like this, that's totally fine. I'm not going to. I'm going to leave my answer like this, 2x over x minus 1. Okay? So again, reviewing, you factor the numerator and the denominator, and then reduce the factors or parentheses that can be reduced. Oh, last one, and we're finally done. Here we go. Well, the good news is you can't factor 2 minus x. I mean, there's nothing common to pull out. I have a binomial. Do I know the square root or the cube root of either one of those terms? No, I do not. And then the other good news is this factorization here is one of the really easy ones. Notice there's nothing common I can pull out. And so next, I notice I have a lead coefficient of 1, and that's the easy kind. So I simply list out the factors of 6. Negative 6, 1 times 6, 1 times 6. 2 times 3, 2 times 3. So negative 6, so a positive times a negative, negative times a positive, positive times a negative, and negative times a positive. Only one of these adds up to a positive 1 right there in the middle, positive 1, and that's going to be this group right here. So the factorization would be x minus 2, x plus 3. There we go. So we factored the numerator could not be factored, the denominator could be, so we factored all of that down. There we go. And now let's go ahead and just kind of extend our fraction. We're going to cross off 2 minus x. We're going to put 2 minus x over here. We're going to cross this off, and we're going to put, and actually, what was that? It's my fault. X minus 2, x plus 3. Wow, we have nothing. Wow. I mean, I'm being a little dramatic on purpose. I know what to do. I'm just trying to get your attention here. Wow. I mean, I wish I had x minus 2, but instead I have 2 minus x. Hold it. I just had a thought. I don't have many of those. I just had a thought. If I can somehow make this 2 minus x and x minus 2, that would be a huge help. I know what I can do. Hey, watch this. I can take my top and I can pull out a negative 1 as long as I change all the signs. Now you might not have thought to have done that, but do you see what I did? I'm going to go over that again in just a second. Alright, look what I did to the numerator, the top. I was like, man, I've got x minus 2 down here. I wish I had x minus 2 up here. So I said to myself, hold on. If I pull a negative sign out front, I can pull a negative out. as long as I change all the signs. So now my positive 2 became a negative 2, and my negative x became a positive x. And hold it, I can rewrite that. I mean, negative 2 plus x is the exact same thing as positive x minus 2, with my negative 1 out front still. So there. Look what I did. I pulled out a negative 1, so the signs changed. Then I rewrote their order, and look what I've got. X minus 2, x minus 2. So, sorry about that. X minus 2 right here cancels with x minus 2, and I'm left with negative 1 over x plus 3. All right? I hope this has helped. Let's get into the review sheet. I want to talk to you about this. Please take some really good notes, and please listen to what I'm about ready to say. First of all, notice, go ahead and copy this down while I'm talking. Notice this is not a short review sheet. Let me get out my eraser here and erase a hidden message that I have typed earlier. There we go. You have a total of 41 problems. Now, before you pick up something and throw it through your computer screen, or in Chase's case, his cell phone that he uses, look, I'm not giving you any homework tonight, and there's no video on Friday. Now, let me explain. There's a video, but the video on Friday is just me working all these problems out for you, okay? So you can split this up into 20 problems one night and 20 problems the next night, plus you have the weekend too. Plus, if you don't want to take the test on Monday, now y'all listening to me? If you don't want to take the test on Monday, you can work on this a little bit Monday too in class. Although I probably shouldn't have said that. I wouldn't recommend that. I would come to class on Monday with this entire review sheet worked out. Now, why would I encourage you to do that? So that you know, for two reasons. Either number one, if you've worked out the entire review sheet and you've watched my most eloquent, awesome video, then you'll have all of your questions ready. And number two, you might not have any questions because you've watched the video that helps you work these out. So you could probably take your test at my house Monday while I'm here to help you answer questions about your test while you're taking the test. Okay? So here's what I'm trying to say, and I apologize if I'm rambling. There is nothing on the test that's not on this review sheet. Okay? Do you see these pages here? All of these answers are in the back of the book. Even the evens, Mr. Earhart? Yes. When you look at pages 52 and 53, it's called a chapter review or review exercises. And they put all of these answers in the back of the book. Now here on page 36, these are not all in the back of the book, just the odds are, okay? But still, you can watch the video and check your evens. So, I would work on this problem. I would work on this review sheet today and Friday. Remember, Friday there's no video to watch as in terms of learning something new. Yes, there's a video showing you how to work these problems out, but there's no new lesson on Friday. And those are about 25 minutes, 30 minutes alone. Then there's homework. So Friday, all you have to do is work on this. Spend an hour Friday working on this, and I'll bet you'll get 2/3 of it done. And then Thursday, today, right now, spend about 30 minutes working on this, and I think you'll get close to all 41 problems done myself. Now, here's the deal. I don't make you do the entire review sheet. I let you choose. But I give you 5 bonus points if you can give me the entire, on your test, 5 bonus points on your test if you can give me the entire review sheet on Monday. All right? Understand? So, when you come into class on Monday, you're either going to ask questions on the review sheet, or you're going to say, Mr. Earhart, I'm ready for my test. And I will probably put you in a separate room, okay? Maybe my daughter's at school, she's gone, she has a desk in her room. My son has a desk in his room. I could probably set someone up in the basement, downstairs in the den taking a test, and the kitchen table also. So we can accommodate whichever route you want to go. But when you walk into class on Monday, you are either ready to take your test totally and completely, or you know where all of your questions are. I would not advise you to walk into class on Monday and say, hey, yo, Mr. Earhart, what's up, dude? I got 1/3 of the thing done, and I'm going to work on the rest of it now. I'm not mad, and I'm not going to call your parents, but I'm saying to myself, man, that's not very smart, because you're not going to be able to ask a whole lot of questions because you're not going to know where your questions are. So my personal advice is come into class Monday either with a lot of questions or be ready to take your test. Now, I'm hoping my video, don't forget, there'll be a video on Friday for you to watch that works all of these problems out for you. My advice is not to watch this video on Friday until you've done the review sheet and checked your answers in the back of the book, and then you'll know which ones you need to watch. That way you're not spending your entire time watching this whole video. It'll be a long video, probably an hour or something, because or longer. I'm working all 41 problems out. But you're not supposed to listen to the whole video. You're supposed to kind of pick and choose the ones that you feel like you need help on after you've worked on the review sheet. Look, there is no reason for you to be confused. You can call me or you can email me, earhartmichael@juno.com. Okay? Some of you have already emailed me with questions, and that's great. I love it. It's fine. So the ball's in your court, as the saying goes. Work really hard. I love all the students I teach, care about you. I know this is not super easy, but it's pre-cal. It's supposed to be tough. So please work hard. I'm here to help you if you have any questions.